Chenab Bridge is located in Jammu and Kashmir region in India. It is a part of the Jammu-Udhampur-Srinagar-Baramulla Rail Link USBRL project. Chenab Bridge has the unique distinction of being the highest railway bridge in the world, spanning at a height of 359 meters above the river. It has been built in some of the most toughest conditions and is really a marvel of engineering. The USBRL project is owned by and being built under the guidance of Northern Railway, Indian Railways. Northern Railways is one of the oldest and biggest railway zones in Indian Railways. The Northern Railway holds its headquarters at New Delhi. Northern Railway, apart from the USBRL project, has a lot of achievements to its name, like the Jammu-Katra Rail Link project. Northern Railway is also currently under the process of constructing some of the toughest projects in the Himalayan region, including the Rishikesh-Karnaprayag project and the Bilaspur-Manali-Leh project. The trustworthy team of Konkan Railway Corporation Limited is in charge of execution of the USBRL project. They have ample experience of working in tough terrains, like the Konkan Railway Network commissioned by them, which was an extremely tough project due to the mountainous terrain and more than 2,000 bridges and 90 tunnels. It was the biggest railway project of the century. The project of construction of Chenab Bridge has been awarded to the Chenab Bridge project undertaking, in which AFCONS is the executing partner. The Chenab Bridge is being constructed by AFCONS Infrastructures Limited. AFCONS is a transnational company with projects in over 25 countries. It is the only Indian company ranked in the top 25 international contractors in both marine and port facilities and bridge sector. AFCONS is also the highest ranking Indian contractor in top 50 international contractors in transportation sector. AFCONS have a huge experience in extreme engineering and construction, and it shows in the construction of the Chenab Bridge. The bridge health monitoring part for Chenab Bridge is being handled by Tranz Rail Solutions along with their partner Strainstall, which is a part of the James Fisher Group. Strainstall is the leading structural health monitoring company in the world, with the health monitoring of many signature bridges in the world in their portfolio. The complete solution provided by Strainstall is unparalleled, a combination of hardware and software which makes monitoring of the structure extremely easy, thus resulting in quick decisions and actions. Tranz Rail was formed with only one mission: to bring in new technology to Indian Railways to enhance the safety of our railway structures. Tranz is responsible for introduction of the latest ultrasonic testing technologies in India, like B-scan with 9 channels, ultrasonic vehicular testing, etc. Tranz is also responsible for getting to Indian Railways a much-needed solution for broken rail detection. At Tranz, the motto is, "Change is the only constant," and they strive to always change for the better. Now let us see the components of the bridge health monitoring system at Chenab Bridge. This is the strain gauge. It is one of the most frequently installed and important sensors used in structural monitoring. Strain gauge measures the surface strain, which can be used to determine other responses such as stress, load, and fatigue life consumption. It is probably the only sensor with a unitless measurement. Its output is microstrain, which is commonly used as the accepted output. On the Chenab Bridge, strain gauges are installed to the steel surface and critical locations on the bridge. This here is the accelerometer. It is a vibration-based sensor which measures the rate at which velocity changes with time in terms of both speed and direction. It often has a 3-axis of measurement. As acceleration is particularly important for bridge structures because it is closely linked to the natural and loading frequencies of the structure, it is a very important part. Understanding acceleration at known points in the structure, which the accelerometer provides, allows for quick and easy comparison against the finite element model to confirm the bridge modal shape, stiffness, and inevitability of its condition. On Chenab Bridge, it is installed at the midspan of the arch. This is the displacement transducer. Its main job is to measure the movement between two objects. This is a highly accurate, robust, waterproof solution for measuring displacement. On the Chenab Bridge, it is installed at selected bearings to monitor both the longitudinal and transverse movement. The information it provides is critical in ensuring that the articulation of the bridge remains within design limits and understanding the cumulative wear of the bearings. Next up is the latest and greatest state-of-the-art GNSS-based deflection monitoring system. It connects to many satellite systems like GPS, GLONASS, Galileo, BDS, QZSS, IRNSS, and SBAS, and thus is very accurate. On such a large span bridge as the Chenab Bridge, the mid-span deflections and lateral movements can become very large and should be monitored continuously to ensure the movements are within service limits. The system has two parts, rover and reference station. It has the ability to output millimeter accuracy positional data through post-processing technology using its amazing software, and offers a centimeter accuracy through the RTK ability. The rover is located at the mid-span of the bridge, and the reference station is located at the bridge control room, which is a fixed location. The system uses both these in conjunction with all the satellites to provide accurate deflection data. This is the inclinometer. It measures the change in angle of a particular location, thus measuring the tilt of an object. It uses a gravity-based technology to accurately report the current angle. Using this information, it continuously monitors the change in angle of the object, thus monitoring the tilt, which is why it is sometimes also known as the tilt meter. On the Chenab Bridge, it is installed at the top of the tallest piers connected to the base of the arch. There it measures the angular change in two directions, giving valuable information on how the piers are moving through train passes and seasonal temperature changes. The angle of the piers is extremely important as it has an effect on the whole articulation of the bridge and carries the load to the foundations. So even though this sensor has a nickname, it is actually pretty important. The embankments below the Chenab Bridge play a critical role in supporting the structure. Extensive strengthening has taken place on both sides of the valley. Ground anchors are installed at a number of places to stabilize and maintain the strength of the embankment. The responsibility of the next item is to ensure that the ground anchors maintain the strength. This is the ground anchor load cell, and it is used to monitor the load in the ground anchors. To ensure the stability of the embankments and look deeper into the ground, this is your guy, the ground extensometer. In the Chenab Bridge, it is being used as a 5-point settlement system to measure the relative settlement at 5 depths into the embankment area. To put it in place, a borehole is drilled at 40 meters into the embankment with rods grouted at 5 selected depths. These rods lead up to the ground level, where the vertical movement of each rod is monitored using an LVDT-style automated readout system. The real-time monitoring allows for continuous monitoring to ensure the embankment remains stable, and any movement is reported immediately to the trackside team. Earthquakes are scary, but out of our hands, and nature rules there. However, what we can do is to monitor and collect data at a very fast pace from our structure in case of any tremors, so we can monitor the structural response to the tremors and identify any permanent changes in the structure. This is where this next one comes in, the seismic sensor. In the Chenab Bridge, it is installed at the base of either side of the arch, slightly away from the structure to detect tremors. In addition, it can also send out automated alarms to the structural monitoring team and also share with them the location of the seismic event and its magnitude, linking to real-time online database of seismic events from USGS. Being the tallest railway bridge in the world, the Chenab Bridge shall be exposed to strong gusts of wind sweeping through the valley. These large wind events can cause the bridge to sway and move. These high wind speeds are detected and monitored by the anemometer installed at the midspan. The anemometer uses ultrasonic technology, which means it does not have any moving parts. This is the reason it is relatively maintenance-free. In conjunction with the other sensors in BridgeWatch software, it generates dynamic reports of the bridge response during high wind speed events and also alerts the team when the train speed should be brought down or traffic halted until the wind speeds reduce. The Chenab Bridge region experiences large sweeping temperature changes throughout the year. This large variance in temperature has a huge impact on such a large mass bridge as Chenab Bridge. The temperature change shall cause the steel structure to expand and contract, changing its position. The changes in temperature are continuously monitored by the temperature sensor in correlation with the data from all other sensors to understand what effect temperature change has on the structure. Now coming up is the heart of the system, the Data Acquisition Unit, or DAU in short. It is a vital component of the structural monitoring system responsible for the collection of data from the various sensors and converting raw sensor measurements to useful engineering units. Chenab Bridge is so huge that two of these have to work together to collect and make sense of all the data. Together, they can take care of the processing and filtering of data, fast and event mode logging, and data checking, all in real time. They are connected to the control room both with a fiber optic cable and also a wireless connection. All the data collected is sent to the main server in the control room. Too much data, yet thirsty for information. This is a common issue with monitoring systems. This is where BridgeWatch steps in to convert data into actionable information for the end users. BridgeWatch is a super smart structural asset management system. With so much data being collected on the bridge, it is imperative that a powerful user-friendly software like BridgeWatch is used to take that large volume of data and place the useful, valuable information at the operator's fingertips. Deployed on a server in the control room, it provides real-time sensor dashboards to the operators. Since it is a state-of-the-art software with nothing else really in comparison, it also has the ability to carry out real-time analysis on dynamic responses of the bridge, providing live event reports from passing trains, high wind speeds, and seismic events. With the automated FFT functionality and integration with RTK GNSS positions, the operators of the bridge are able to easily identify mode shapes and maximum deflections through the various events. In addition to the real-time and advanced reporting functionality, BridgeWatch also ensures that all data is at the engineer's fingertips with actionable information and many tools for custom analysis. It is also fully customizable and can be programmed with any of the custom calculations which the engineers want from the data, thus saving a huge amount of time for the engineers managing the bridge. It can also send out any number of alerts based on the data from any of the sensors or a group of sensors, fully controlled by the engineers and easy to set up. BridgeWatch is the interface between the hardware and the engineers, and it is really good at what it does. On top of it all, BridgeWatch can be used on any laptop, tablet, or smartphone from anywhere in the world. If the data acquisition unit is the heart of the system, then BridgeWatch is definitely the brain of the system. So this is how the Chenab Bridge is being continuously monitored by a variety of sensors and the software BridgeWatch. All of them work tirelessly 24/7, 365 days in a year to ensure the safety of the bridge and the people using the bridge. Thank you.